Hello, everyone, and welcome to this seminar of the Computational Humanities Research Group. Today, I am very happy to introduce Dr. Yuri Bizzoni, who is Senior Researcher in Computational Linguistics at Aarhus University, where he works on computational narratology, sentiment and emotion modeling, and large-scale analysis of literary style and interactive tools for story generation. He's interested in how computational methods can deepen our understanding of reader engagement, literary quality, and the emotional impact of text. So over to you, Yuri, for your seminar, Living More Through Narrative.
Yes, thank you very much. So thank you very much for coming. And as Barbara said, so I'm Yuri Bizzoni, and this is Living More Through Narrative, Measuring Imaginability and Evocation. This is going to be kind of a I try to give an overview of work that we did through different papers. So it's kind of like kind of an umbrella talk in the sense that I'm trying to see the story that we try to follow through this different research. And in the end, I'm also going to try to show some code. I don't think the code is super interesting in the sense that it's a very simple code. It was actually all coded by, mostly coded by my colleague, but as Barbara was saying, at least if you want to reuse the data or the resources, then you can at least have an idea of where it is and how it might look like. Okay, so this talk is divided in 4 parts. So first of all, the general introduction of what I call living more through literature and what I mean by that, and then 2 main segments of experiments, one about sentiment analysis and the other one about sensory analysis, if you want, which mainly focused on the visual sense, and in which we also use the images poetry, and then the conclusions. Okay, so like the main line of this research started, I think, with a very large idea or question, which is the idea that literature's goal might be that of extending our experience. Of course, in some sense, it is a provocative question because it's rushed to ascribe one single goal to literature in general. But I think that we could have like good arguments to think that this is at least one of the main things that artistic literature does, in the sense that, you might say that why use, like from rhymes to metaphors to dialogues to all sorts of literary devices to communicate something when you could actually, from a simple perspective of essential, let's say, concept communication, you could of course like crush it all in few lines. So like, why would you go through let's say the extent of writing like a poem like this one of Baudelaire here, when in theory you could, of course it's kind of a provocation, but in theory you could like kind of say the same thing in one Wikipedia line. And the idea is that, well, when you read the poem of Baudelaire, it's not only that you learn that the poet is a docile lover with respect to the idol of beauty, but that you have an experience. So you, the poem manages to make you visually really see, for example, the statue of beauty and really feel, let's say, the kind of threatening appeal of this idol, if you want. So it's not only that it's communicating you an idea or a concept, but it's kind of creating an experience in your mind. It's kind of, in that sense, I meant living more through literature, and you can imagine also it with prose and so forth. So in that sense, I think we might distinguish in a fuzzy way between informative and perhaps experiential texts, with the idea that an informative text aims at communicating a piece of knowledge, while an experiential text aims at creating an experience in the reader's mind. Of course, this is like, how can I say, it's a division that can be quite questionable under some respects, but is to understand a little bit the line that I'm trying to follow. So again, like you could summarize, let's say, the young Werther in one line, but if you read the young Werther, it's not only that you learn that there was this young man suffering for love, but you have the experience of the sufferings, and you have the experience of seeing Lotte and of all what Werther goes through in some sense. So it's not only the communication of a piece of knowledge in the dry sense, but it is something that tries to make you go through a new experience that in some sense might be a little bit lifelike. So to simplify, I will call these aspect of literary communication, in this case evocative. There are 1,000 names. I don't think the field is kind of really converge on one name. Somebody calls it immersivity. Here I will talk about evocation, because by evocation I mean the evocation of an experience for the readers. And in this talk, I will go through two different kinds of evocations. One is the possibility of evoking feelings. So in that case, the feeling is not necessarily mentioned, as we will see, in the text, but is felt by the reader, even if it's not mentioned in the text, which means that the feeling kind of happens in the reader's mind. The reader feels the feeling, if you want, he feels the emotion. So it's an experience. And the other kind is evoking, let's say, a sensory experience. So an object, a scene, and so forth is not just described in the way that you could just go through, let's say, an IKEA catalog kind of description, but the words are used for the reader to actually perceive the scene vividly, to feel in some sense as if they are seeing, smelling, or they are in the scene, and so forth. Okay, so this is the general topic that I find very fascinating, again, because if we bring it to the extreme, it's in some sense an expansion of the limits of our life, if you want. But as a computational literary study person and a computational linguist, of course, the question is, okay, can we actually somehow encode it? Can we actually somehow start defining this to the point that we can quantify it in some sense? So I will go through our attempts to start doing this. These are like early steps, because if you can imagine, this is a very complex topic. In the first part, so the what I call sentiments and machine, I will look into the evocation of feelings mainly. So evoking feelings covers a vast ground of many narrative and poetic mechanisms. But I think one good and concrete example of this distinction between what is an informative text and what is what I call an evocative or experiential text is the device called objective correlative. The objective correlative is a literary device that was formalized, I think, by Ezra Pound, if I'm not mistaken. But anyway, it's a device that implies the fact that you use a series of objects. They don't have to be like physical objects, and can also be something like the weather and things like that, but like in some sense concrete elements to evoke a sentiment, an emotion in the reader. So you never mention sadness, but you can go, you know, like the sky was gray and the car were and the city was full of shadows. I don't know, I'm just making something up. But for example, like the Lady Macbeth's spot of blood on her hands can be considered, for example, a case of objective correlative. So objective correlative is one device among many that is used to not just tell the reader it was a happy day, but to make the reader feel, for example, the happiness and so forth. To kind of study objective correlative and start seeing if we could start quantifying this element of evocation, even if it's so slippery, we started with sentiment analysis. So for those who don't know it, sentiment analysis, I mean, I think it's very known, but it's an attempt, it contains all of those natural language processing or computational linguistics attempts at quantifying the sentiment contained in a piece of text. It's usually based on words, contextual balance. So usually the prototype starts with just ascribing some words a positive or negative valence, so that death is considered negative and great or beauty are considered positive. And then those kind of elemental balances are combined by the context of the words in a piece of text to say, okay, this text is rather negative than positive. It was mainly developed for commercial purposes, but then it has been fine-tuned for also narrative analysis. And the beauty, in some sense, the point of using sentiment analysis is that classical sentiment analysis, most of it actually, works best with explicit expressions of sentiment. So most instances will be most responsive to explicit sentiments. But on the other hand, the human readers might actually react, if you think about it, to sentiments that the systems don't necessarily see, like those evoked by an objective correlative, as you were saying before. Now there is a different story now with large generation LLMs, but that's for another talk. But in general, you can imagine that if you are explicit, so if you say like in the beginning of the Werther, how happy I am that I'm gone. Both a human and a machine might say, okay, there is the word happy, so this is happiness. But if you use something that is subtler, so for example, this text from Shakespeare, to bed, there's knocking at the gate, come, 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 give me your hand, was done, cannot be undone, to bed, to bed. A human can perceive that that this is a rather negative sentiment in the text. But the machines cannot find anything that is explicitly negative, and so they might consider it neutral. And so why do we like this failure? Because this could be a crack into looking into a deeper expression of sentiment, rather in the evocation of sentiments rather than their explicit statement. So the question was whether we can allow this, we can use these shallow sentiment systems of sentiment analysis to gather these points of implicit sentiment expression, right? And so if we can use them to disentangle what is what is an explicit expression of sentiments from their own evocation. And this is what we did also in these two papers here. What we did to start was that we took one literary text to in order also to be able to really study what was happening, and also because to be contained. And we took The Old Man and the Sea, and we decided, and we annotated sentence by sentence for sentiment. So the reason we went for The Old Man and the Sea, there are many reasons here. First of all, that Hemingway is known for his iceberg technique of writing, which is a technique in which that explicitly says that you should try to imply rather than say as much as possible, including sentiment. So you should not, if you can, I mean, he does it in a number of occasions, but you should not, in some sense, necessarily say that the character is sad or happy, or that this is an happy scene or anything, but you should try to make the reader do the connection and make the reader understand that that, for example, the character is sad, and it is often said through making an evocation of the sentiment rather than explicitly stating it. Another advantage of The Old Man and the Sea is also that it's a very simple linear narrative. For those of you who read it, it's one of the simplest great works of literature, I think, of the 20th century. It's almost single character, so it was also very easy to follow and remove some of the problematics of annotating, for example, multi-character perspective or shifts in scenes. But generally, this iceberg technique was very good for us, and the general approach of Hemingway to this problem was pretty interesting. For example, here you have a piece of the text. He says that the blotches on the old man face were as old as erosions in the fishless desert. This feels very sad and heavy, but there are actually not really many words that are considered sad in the sentiment analysis tool. So first of all, we annotated them, and this was already the first interesting part, because the question is whether we as humans agree on giving a 0 to 10 scale of sentiment to all the sentences of a literary text. So whether we, like we were just sitting in a sad, boring office room, whether we would converge enough. And interestingly, with variations, we did converge. So we had an overall annotation agreement of Spearman correlation of 0.65, and after the trending, which is a way of looking at the general line of a sentiment arc rather than and removing a little bit of the noise, we went up to 0.92 Spearman correlation. So we really tended to agree. There were some cases in which we didn't, which were pretty interesting, but initially we agreed with each other pretty much. And then we took a host of sentiment analysis tools, many of them being large language models, and we asked them to annotate The Old Man and the Sea sentence by sentence. And once we had done this, we could look at the points in which the humans had perceived an emotion, either positive or negative, and the systems had not. And we found that this group of sentences in which the humans perceived an emotion and the system not was actually mostly the same for all models. And this was a group of sentences in which if the humans perceived an emotion, but there was nothing so superficial enough for systems, even quite advanced systems, to find the emotion, it means that the emotion was, in some sense, evoked in the reader's mind. It was not just explicitly stated. For example, here you have like an excellent example down on the left. And so we took this group and we wanted to see if there were some characteristics to this group that kind of systematically told it apart from the rest of the sentences. And of course, you could look in many directions. We went for the other dimensions of the VADA model. So the VADA model is the one on which most sentiment analyses rely, which is a psycholinguistic model of sentiment in words, and it's based on 3 dimensions. One is valence, positive or negative, and the other two are arousal and dominance that are in neurolinguistic studies, they're strongly related with valence, but they're more like the level of excitement or arousal that the word provokes and the level of dominance and control that the word provokes. They seem to be very related to the three, to each other, so we went for them. And plus, since we were looking for objective correlative, we look at concreteness. We have dictionaries of concreteness. And what we found is that indeed there was actually a statistically significant difference for some of these dimensions. And specifically, we found that concreteness and arousal were statistically different and systematically different in their level between the explicit and the implicit group. And there was a systematically higher concreteness. So actually, the words that evoke the sentiment were really much relying on the concrete level, just as the object correlative would predict, if you want. So it seemed to be happening. And also interesting, the arousal level was down. So they were not trying to use, the writer was not using very exciting words, at least at the level of these dictionaries, but it was really kind of describing a situation almost in a low key, in a way that that would arouse the sentiment in the reader. Okay, since we have these results, then I'm about half the talk. Yeah, good. So since we had these results, we went for then a larger study. So we collected a larger corpus in which we included both elements of poetry, chosen elements of poetry with some rationale, prose, and also several categories of nonfiction. Some of these have been collected before us and we reviewed them. Some of them we collected ourselves. You can find the details in this paper, and it's also online for you to use. And basically, then we had like human annotations, especially the poetry. The nonfiction had already been annotated, and then just like we did with Hemingway, we had the models re-annotated. And again, we found that there was this consistent group of implicit, what we call implicit, of sentences, both in fiction and non-fiction, in which the humans felt an emotion, but the systems could not find it, so to speak, on page. Many of them are in fiction, but also, for example, in other elements of non-fiction, like tourist guides, interestingly. And when we looked at several dimensions, again, arousal, dominance, and concreteness, we also looked at some other interesting elements like sensory related, what is called haptic, interoceptive, and so forth. We found that we had the same mechanism that we had found for Hemingway. So again, there was a downplaying for the dimensions also called intensity. So the arousal was systematically lower. Also the dominance was systematically lower in this case, and the concreteness went up. So again, it's exactly what you would have imagined if these things were playing on the level of the objective correlative. So there seemed to be a subtler, as I said, as I call it here in some sense, a subtler and less explicit form of communication that some people call omissive evocative strategy, but it's ubiquitous. It's really like a form of sentimental evocation in which the reader, to an extent, feels the emotion rather than just knowing that it's there because it's stated. Okay, so this was the first part of the work on evocation of sentiments. Now we'll move to our later paper, which is called Encoding Imagism, which tries to take the same question instead on the side of sensory evocation, because we have looked at evoked sentiment, but what about a more general sensory evocation? So what about that kind of writing? Well, actually, I don't know if this Mishima quote is the best here, but like the kind of writing that makes you feel like vividly, like you're seeing, smelling, or touching something, like you're really in a scene, which is another form of experiential text, if you want. So we are not the first one in absolute to try to study this with quantitative means. Computational literary studies already employ some psycholinguistic measures, like, and these are measures in which, just like with concreteness or valence, they gathered many people and they asked them to rate words, usually with some scales. And these measures are, for example, measures of imageability and visuality, meaning that imageability is how much a word evokes a sensory experience, and visuality is how much a word is connected to the visual sense. But in some sense, these are kind of, well, they're very good. But of course, again, there are resources in which you gather people and ask them to give one single number to a word that could have a vast variety of let's say, sensorial content and also sensorial associations, if you want. So it's necessarily reductive. But what we have now is that we have something like if you want, much more powerful to an extent, which is the multimodal word embeddings, the multimodal text embeddings. So these are word or text embeddings that capture extra-linguistic associations over a huge amount of text and of images. So in the end, when you have a word or then a sentence, you can connect it, like you have all the linguistic distribution information of the word, but also all the extra-linguistic, mainly visual information of the images that that word is connected to. So in some sense, these are claimed to be closer to what is elicited in a reader's mind when they hear or read the word, for example. And we don't need annotations in this case. It kind of go in some sense straight into the word's nucleus with its richness, right, of different kind of contents and associations. And so we wanted to look if we could use these multimodal embeddings to go beyond single dimension imageability and visuality and study evocation, sensory evocation on a richer scale. And so our question was, since the embeddings can capture this richness and variety of the content of a word, whether the structure of the information encoded in the multimodal embeddings can tell us something about their visual and imageable power. Because of course it would have very interesting implications for the semantics of immersion. And to do that, we went for several measures of how the information was encoded, but the main two that I will also present the results for now are entropy and norm. So the entropy of an embedding is whether the information is diffused in many dimensions. So if an embedding has like a strong information, for example, in many dimensions, the entropy is higher. While instead, if the information kind of peaks on only one dimension, that has a low entropy, but tendentially a very high norm, to simplify. And so we wanted to see if this kind of richness versus intensity of the multimodal word embeddings could tell us something about the evocative power of the sensory evocative power of texts. So now this was actually a quite challenging task because we didn't have many previous studies to work on. So we had first of all to kind of formulate two hypotheses and see which one was actually the case in order to then move and test these systems on let's say poetry. And so we had kind of two competing mutually exclusive hypotheses. The first one was so maybe imageable and concrete words have multimodal embeddings that have a more localized activation, because maybe, you know, like if you have something like dog can be very visually consistent, and so maybe it activates, let's say the information tends to be more squashed in one dimension, whether if you have something more abstract like beautiful, maybe it's associated with many different things. But at the same time, it's also true that at the visual level, something very concrete or more concrete, like for example, again, dog, has many dimensions that are important because you are able to recognize dog, let's say, well, in some sense, it's visually belonging to dog, both the ears, the tail, the legs, and so forth. So there are many dimensions that are relevant, while something abstract might be actually more narrowly focused on the purely linguistic context and not actually have much of a visual richness to communicate. So these were actually our two linguistic competing hypotheses. And what we did is that we computed the entropy and norm of all the embeddings in the dictionary, in the psycholinguistic dictionaries, and first of all, so whether they correlated with measures of imageability, visuality, and concreteness as those assigned by humans. And what we found is that there were actually correlations, and interestingly, especially imageability and concreteness had quite robust correlations with norm and entropy, and they had positive correlation with entropy and negative with norm, meaning that words that have a high entropy and a lower norm tended to be more concrete and more imageable based on these elements. Also very interesting, we did not have this correlation when we used text soul embeddings, like the embeddings from birds. So this is really something that comes from the extra linguistic information of the multimodal word embeddings. So the hypothesis number 2 was actually confirmed. So there is something there actually very much, and it's a matter, the more imaginable and concrete words tend to have a wider richness of visual content, of content in that sense. But also it's interesting to see that these were like robust but not super strong correlations, which means that these things are not capturing exactly what like that kind of narrower definition of imaginability and visuality and concreteness are trying to define. They're capturing, if you want, something else that in some sense encompasses them. Okay, so we had these 2 measures that were promising, and then we first of all went into 2 corpora of fiction, and we looked whether we could reproduce these results on the level of sentence embeddings, because you can also have like sentence visual multimodal embeddings. And again, we saw that both in the Just the Old Man and the Sea and what we call the Chicago corpus, which is a huge corpus of fiction, we could see that there was an inverse correlation between norm and concreteness and a positive correlation between entropy and concreteness and visuality. All right, but then we wanted to see whether it was actually telling us about evocation, right? So what we did for that, this was of course very tricky because how do you do it? And what we did again as a first step was to go for imagism. Now imagism is a genre in poetry that bloomed in the first half of the 20th century that had the exact explicit goal of creating an image, a vivid image in the mind of the reader. That was their explicit sole scope. And so even among different kinds of literature, imagism is supposed to like try to be as sensorily vivid for the reader as possible. And we compared it with a very strong baseline, which was a collection of, not modern, sorry, this is a typo, but of love poetry. So it's still poetry, so it's still going to be quite vivid and visual in some sense. But the idea was with such a strong baseline, if imagism actually shows a difference at the level of entropy and norm, then there might be actually something there when it comes to evocation. And what we found is that indeed there was a difference, both at all levels, the levels of manageability, visuality, concreteness, but also at the level of norm entropy, and also a little bit sparsity, which is another dimension of another kind of measuring the distribution of the information. So what we found is that those texts, images could be like statistically significantly, in a statistically significant way, told from the other ones based on these, told from like love poetry, like based on these elements. And we found that first of all, concreteness remains the strongest signal. And I think this is because concreteness scores involve all 5 senses, which is extremely important in poetry. But all the purely visual measures were bested by the multimodal embeddings inner structure. So it really seems that evocative texts are marked by multimodal richness, which is absent in just unimodal. So it's really something that has to do with the extralinguistic information. Okay, I'm about coming, I think, towards the end. How many minutes do I have left before the code? Well, I think I should be good.
It's flexible, yeah.
Yeah, sorry.
Say you can have 5 minutes, but it's up to you.
That should be fine. Yeah, but anyway, I am at the conclusions. So basically, this is a bit of a dense slide. That's why I was asking. But basically, I think we have started quantifying. We started quantifying in a little bit, or looking at ways to quantify traces of evocative strategies in writers, by evocative meaning what I said in the beginning, the experiential texts. And the level of sentiment, we have seen that they are systematically characterized by higher concreteness, but also, which was interesting, lower dominance and arousal. So they're perceptually rich, and they have a heightened vividness in that sense, but it seems like they also take care of make the reader carried by the scene. So the words that are that has a strong element of control and a strong element of excitement are like toned down, which might reduce the detachment of like, let's say the narrative detachment, if you want, could like make it more immersive in some sense. And the sensory level, we found that there is a higher multimodal entropy. It seems to be associable with the stronger perceptual text, stronger evocative text. So words with more strong visual dimension. And these seem to be words that have multiple sensory traces, at least at the visual level, and so also probably associative traces, which might also have to do with readers being able to construct the scene in the sense that you can choose from many, many dimensions of the visual part. So there seems to be a connection of like simulation potential and a little bit of flexibility in the imaginability level. But of course, this is like very early days. So like these were like, I think, kind of smart if you want ways to start looking into this very complex dimension. The question if these effects make the reading experience more real is still open. I will be fascinating also in the question if we can push this to new borders. So if we could actually use this knowledge once it's more mature to artificially push a text to be more evocative and make let's say kind of almost in a kind of new imagism way, trying to make the experience of the reader more and more real-like in pushing, let's say, the concreteness and reducing dominance and so forth. So it's a fun mind experiment, but it would be an interesting direct kind of provocative direction to look towards. Right now, we are launching a citizen science project together with Andrew Piper to annotate immersion. So we have actually triangulated with Piper, Pianzola, a series of researchers in Europe and in the States to try to do a large project in which we will have chosen pieces of literature online, and we will ask to as many people as possible to annotate on whether they feel like they were there, in some sense, whether the immersion, the effect of real or lifelike is very strong. Also because we have seen that there is, I couldn't put it in the presentation not to make it too long, but basically we have seen that there is a correlation between this possible evocation power in the way we measure it and the scale of narrativity that Piper measured. So there seems to be also something that is really ingrained into strong storytelling. So we are building this, and let me know if you want to participate in some form to this, because you're still building it. In general, the idea would be to have a lot of readers annotate to this and then see if there is if they agree, and if there is something in those texts that kind of allows this kind of extension of life in some sense. Okay, so this is my presentation. And I think in the remaining 10 minutes, if you want, I can show you a little bit of the code. So,
yeah, please.
Yeah, sure. As I was saying, the code, I mean, I don't think the code is anything mind-boggling. Since I presented different experiments, I can show you a little bit the one from the last one, that is the one maybe from a code perspective a bit more complex, but in general know that almost everything of what I presented is online. If you go on the Center of Humanities Computing, you're going to have most of our code for all the papers that I presented. This one, imageability, is the one on imagism. And as you can see, I have to say to say that like merit where merit is due, most of this code was actually written not by me but by my co-author. So she actually did all of the effort. But basically here you can see we have, if you download this, most of this should work. I think there is only one small bug that we're working on. But these are the three experiments: one on word level, one on sentence level, and one with images that I was showing you. And basically these can be run independently. So each time you have all of everything you need to just run these ones on their own. As you can see in this case, for example, we start by I don't know if you want me to go this like level to level, like kind of line by line, but basically we start by opening the CLIP model, which is the multimodal model that we use. And we take it here. And then we access a series of chosen psycholinguistic dictionaries to have the values of concreteness, imageability, and visuality that we compared them to in the first experiment, if you remember. And so in this case, we used this MRC dictionary for imageability. We have the sensory motor norms. We have the concreteness, and then these two extra dictionaries also of imageability that kind of try to improve the measures. So you just kind of very simply load them all and make like these one value dictionaries if you want. And then at that point, what we need to do is to get the embeddings for all the words, in order for us then to compare. And so here we just create, well, we take the embeddings for those words, and then we do the computation of those measures that we found might tell us something about the inner structure, inner information structure of the multimodal embeddings. So simply the norm, which is one line, and then we have, as I said, we also have more than norm and entropy. So we have also one for entropy, which is very simple. Basically, you just turn them down to probabilities and then calculate the entropy. This is a variant of entropy, softmax entropy, that didn't give any different results, so we commented it out, but you can always use it. And so we get the entropy, and then of the embeddings, and then we also had other measures that could be interesting, although in the end we found that the results were not anything different, and they're a bit weaker than entropy and norm, so we didn't put them in the I didn't put them in the slides. But we also look at variance, skewness, so whether the text, whether the information had to be like very like, let's say, very skewed, as the word goes, right? So whether there is a strong difference between the high values and the low values, kurtosis, which is a variation of this concept, and then we also have sparsity, which is how sparse the information is, if it's all over the place or tends to be in one part of the embedding. And then basically here we go for the plot. It's very simple. We put them in a data frame, which is always good for plotting. We have imageability, the extended version of Really and Cortes, visuality and concreteness. And then basically we just do the correlation and we do the PLT. And this is what we saw here, just the heat map. And then to compare with BERT, this part actually we have to add BERT, so it might give you an error, but if you add BERT, it is to just show that just extremely powerful but just text-based embeddings do not have the same correlations. Here we get through all this long procedure to upload BERT embeddings, and then you can redo the same things, compute its kurtosis, its variance, its entropy, and do a new correlation table. This is like what was the first experiment, and then in the second one we do the same but with sentences. Again, like it's we re-upload everything in every case. We have the same, like we kind of copy pasted the same functions for every code. But basically here you can access a chosen selection of 9,000 sentences from this large Chicago corpus, because we cannot unfortunately read the whole corpus. And then basically you can create multimodal embeddings for the whole sentences and not just for their words by words. And then you do the same. You just get the dictionary score for all the sentences. You can decide if you want to normalize by length or not. And then you can have like in the end, what you get is in the end is still a very simple statistical test in which we visualize the difference and look if they're statistically significant or not. And if you want to play with images, in experiment 3, you can go and have, again, you upload you load the models, and basically you can go here. We have some images, and you can divide them by poet or by text, depending if what you want. And you can divide them by sentences, which actually we call them sentences, but this is wrong. This is by line, because of course, like breaking the poem by sentence doesn't make sense. So it's line by line. Or if you want to have the whole poem in one bunch, and then you can compare them with the love poems that should be later here, and then see the difference. So these are the main 3 experiments that I presented. There is also this extra narrativity experiments that is about the level of narrativity in text. To be honest, I have not looked at this code because it happened very recently. But basically the idea is that we take this annotated data set in any case of annotated for narrativity, and we see if there are correlations with norm imageability, visuality, and so forth. And there were there were robust correlations. So basically, if you do this with the BERT caveat that I said, which we are going to fix very soon, you can just rerun them and have the same results as us, and then you can play with our images, narrative, and love poetry data sets. as you want. And then also, in case you want that larger corpus that we call fiction 4 for sentiment in this case, you can also find it here in the Center of Humanities Computing under literary evocation, of course. And in this case, this is this corpus of several different sentences annotated by sentiment, and this one is called Fiction 4. And here we have Hemingway, we have poetry from Sylvia Plath, we have a collection of fairy tales. We chose them for a series of reasons in order to cover different kinds of poetry and prose, but also have something simpler like fairy tales. But we also have Emo Bank. So Emo Bank is a collection of sentences from different kinds of non-fiction genre, like newspaper, but also tourist guides and so forth, that have been annotated manually by sentiment and also emotions. And so you can kind of, this is the new one, the one that we produce Fiction 4. You can download it and you have both human annotations on them made by several different humans, and you have several different sentiment analysis models annotations, sentence by sentence for prose and line by line for poetry. And then you can try to have fun and repeat our analysis, which was basically just seeing if, looking at the implicit, so when you have the strong difference between the results of the models and the results of the humans, and then see if there are differences at levels of concreteness, arousal, dominance, and so forth. As you can see, the code, this is working code. So I was also like, if one of you is a programmer, this can be optimized in 1 million ways, and hopefully we can go around and do it. But it's all well commented, and it works. I mean, you can download it and it should work. These thresholds are important, just in case you want to actually go and play with this. These are our thresholds to decide if the humans did feel something and were not neutral. Since the scale was continuous between 0 and 10, we decided to put a threshold at 4. So if it was lower than 4.5, it meant that the humans felt that the text was quite sad, and it was higher than 5.5, felt that the human felt that the text was at least a little bit happy. But you can extremize them and you have the same results. So you can play a little bit with that up to the point in which you just don't have enough data point to say much. And then you can put the threshold, of course, for the system's results. So the code is here, is not, let's say, industrial code. So it's of course like quite like one that initially in one long scroll, but it does what it should do, and you can play with our data both here and in Imageability JCLS. We also have the Hemingway ones, but for the Hemingway, you have, I don't know if I can find it. It should be just Hemingway. So the first study that I presented, no, okay. We have it, but it's just a JSON, so you don't have the code. We can try to add the code if you're interested. The code is very simple. It's basically just doing what I showed before, and try to see when the humans felt something and the machines not, so to speak. So yeah, I guess that's it from me, at least in general. And
yeah,
you can tell me if you have questions.
Thank you very much.
Thank you.
Yeah.
Thank you.
Okay.